graphing linear inequalities. These are actually one of my favorite things to do, so I hope you find them as fun as I do. We will be graphing equations that have inequalities in them. So greater than or less than, greater than or equal to, or less than or equal to. Let's start by quickly reviewing how to graph equations in y equals mx plus b form. Recall that we begin by graphing the y-intercept, -4, and then we move to the slope, m, which is 3, and if it's not a fraction, remember, we put a 1 underneath the 3, which helps us to graph this equation, because now we know we go up 3 over 1. So up 3 over 1. And remember, you start from -4 to count your up 3 over 1. And then we simply draw the line. Arrows on both ends. Try to make it as straight as you can. Here's another quick example to refresh your memory. We begin at 3, the y-intercept. And then the slope is -5 over 2. Since it's negative, we're going to go down 5 over 2. So I start at 3 and count down 5. 1, 2, 3, 4, 5 over 2. Connect our dots with a straight line. That wasn't super straight. So we're going to apply this knowledge to graphing inequalities. But there is a twist. I'll show you that in a second. We start this equation by graphing a dot at 3, our y-intercept. Our slope is a 2, so put it over 1. That tells us to go up 2 over 1. And now here's the trick. Our equation is y is greater than 2x plus 3. Anytime we have a greater than or a less than sign in our equation, that is like an open circle when we graphed on the number line. While graphing a linear inequality, instead of an open circle, we use a dashed line. A dashed line is the same thing as an open circle. So when I draw my line, I just want to make it dashed or dotted. There's one more wrinkle. This equation is y is greater than 2x plus 3. Any point that's bigger than this line would work in this equation. So what we do is we add shading to the graph. Since it's greater than 2x plus 3, we shade above our dotted line. This side is called above the line. This side is called below. So any point on this side of the line would work in this inequality. And any point down here would not work. So we're actually shading the answer to this inequality. Again, I think these are kind of fun. Let's move to our next example. We start at 4. Make a dot at 4. The slope is -1 over 2, which tells me to go down 1 over 2. Down 1 over 2. Again, there's not an equal sign in this inequality, so that means I must use a dashed line. Then I look at the symbol. Since it's y is less than the line, I'm going to shade below my line. And remember, the shading means the points below the line work in this equation. And what do I mean by work in the equation? Let's pick a point down here, and I'm going to pick an easy one, the origin, which is 0, 0. If I plug 0, 0 into this inequality, I get 0 for y is less than negative a half times 0 plus 4. Well, negative a half times 0 is simply 0. So I'm left with 0 is less than 4. That is a true statement. 0 is less than 4. So every point below this line would give me a true statement if I plugged it into this inequality. Any point up here would give me a statement at the end that was false. Now, the dotted line is like an open circle, which means that the points that are on that line don't work in this equation. They would not give you a true statement. So the line itself is not part of the answer, but all the points below it are. Let's try our next example. Y is greater than or equal to 3/5 x minus 3. Start at minus 3, our y-intercept. Our slope is 3/5, so I'm going to go up 3 over 5. Now, this time there is an equal sign as part of the inequality. And a greater than or equal to and less than or equal to are like a closed circle. When we graph lines, a closed circle is just a solid line. So to graph this inequality, I just make a solid line. Since the inequality says y is greater than or equal to the line, the answers that work, the points that work, are above the line or greater than the line. So my shading is in this direction. So all of these points would work in this inequality. If I chose a point again, let's choose 0, 0. I like to choose 0, 0 because it's really easy to plug into the equation. If I plugged in 0, 0 for x and y, 3/5 times 0 would just be 0. 0 minus 3 is negative 3. You'll notice 0 is greater than or equal to negative 3. So this point made this equation true, which means it's part of the answer. It's part of what I would shade. Any point down here, if I plugged it into this inequality, I would end up with a false statement. Let's try this one. The y-intercept is 3, so I start at 3. The slope is negative 3 over 2, which tells me to go down 3 over 2. Again, there is an equal sign on this one, and when we have an equal sign, remember, that means a solid line. Now the shading, since y is less than or equal to the line, I'm going to shade below the line. So again, points on this side of the line will work in the inequality, points on this side will not. Since the line is solid, that means that the points that are actually on this line would make this inequality work as well. Now, for this example, think back to when we graphed y equals 4. That was a horizontal line at 4. So I'm going to draw a line straight across at y equals 4. But since its y is less than 4, that's like an open circle, so my line needs to be dashed. Since y is less than 4, I want to shade below the line. For this one, x is greater than or equal to negative 3. Think back to when we graphed x is equal to negative 3. That was a vertical line through negative 3. Since there's an equal sign, this line is solid, like a closed circle. Then I have to think, where are the x's bigger than negative 3? Well, the x's on this side of the line are bigger than negative 3. So I would shade to the right. My last example, I wanted to do one like this. We're missing the y-intercept. There's no number over here, but I do have a slope of 2. When they don't give you the y-intercept, it's 0. Put a 1 under the 2, I would go up 2 over 1. Since there is not an equal sign, I must make this a dashed line. And since its y is greater than 2x, I want to shade above this line.